Good afternoon.
Good morning.
Good morning.
All right, who said good morning?
That was me.
Clancy.
I guess you'd rather be in bed still, probably.
Yeah.
That's expensive.
Yeah, I think it took me a couple hours to wake up today. Okay, so today we are going to start on 6.3. But before we do that, I'm curious to know, did anyone have any problem with the first quiz as far as access, getting the questions, answering them, getting the highest score, any of that? Any issues at all?
I would ask or question, but there's some people in this class that haven't taken the quiz yet.
Oh, right. No, I'm not. I'm just asking about if there were any problems with the Moodle, basically, or the setup.
Oh, it was really good. Everything looked good. Pretty easy to access.
Okay, good.
Yeah, I liked it a lot.
Okay, good.
I have a question, Mr. Strong.
Yes.
On your test, like your quizzes now, have you changed it to did you change it to where, on like your second attempt, like one or two of the questions are changed?
Yes.
Okay,
Yes. So it's going to scramble the answers. So sometimes if the same question is on there, the correct answer might be A, the first attempt, and B, the second attempt.
Yeah.
So you've got to go with the answer, not the letter grade. Not the letter. And then it's supposed to randomize the questions a little bit too. So it could be you have slightly different questions as well.
Oh, okay.
Okay? But you get the highest score. Okay? So I kind of realized today that I guess I got to quit putting, if I'm going to give you the highest score, I got to quit putting true false questions on there because that's pretty stupid. Because then you always will, anyway, whatever. We'll see. Okay. So anybody absent at Mogollon today? Let's see. We've got. Who said they were going to be absent? Nobody? Okay. How about Hopi?
Everybody's here. Taylor should be coming in.
Everybody's there at Hopi? Aren't we missing somebody?
Taylor's coming in.
Oh, okay. I thought she was going to be out today.
We'll be here for about 10 minutes.
Oh, okay. All right. And how about at Alchese? Anybody out today? Okay.
Denicia, Brianna, and Aliana. Ariana.
Oh, yeah. So I heard from Denicia and Ariana, and you say Brianna also. Thank you. Okay. All right, well, let's go ahead and start with 6.3. Okay, so today is really the first day where I'm convinced that most of the stuff that we talk about today will be new to most of you. Okay, because I know in geometry you do SOHCAHTOA, you do the basic trig functions and so on. What we're going to do is go past geometry. If you remember, we had a if you remember what we had a deal where in geometry everything's focused on the triangle, but then on the first day of class I told you that we're going to have that trigonometry sort of changed to a study of functions. where instead of everything being part of a triangle, then we look at different functions. So that's kind of today, we're going to look at trig values as functions. So we'll do that, and then we'll talk about reference angles, and then relationships between the different trig functions. Okay, probably not going to get through all of 6.3 today. So now, but before I forget, remember Monday I'm not going to do a broadcast. So Monday, I'm asking you to do the Moodle quiz for 6.2 during class time. Okay, so you'll have class time so to do that quiz, and then we'll come back on Tuesday and we'll kind of finish 6.3. All right. Any questions on that?
Wednesday, will we just not have a quiz then?
So Wednesday we'll either not have a quiz or do a quiz on 6.3. We'll kind of talk about that on Tuesday. See how you guys feel about 6.3. Okay. So I would, in a way, I would kind of prefer, because then we can continue to only have one quiz. If we don't have a quiz on Wednesday, then probably the following Wednesday we would have 2 quizzes. So it'll all work out. So, okay. So, all right. So extending the domains of the trigonometric functions. It says, let theta be an angle in standard position with xy, a point on the terminal side of theta. All right, so here's our angle in standard position. So the initial side is the x-axis, and then we measure up, and there's theta. And then on the terminal side, just anywhere, we're going to randomly select a point and label it xy. Now, r stands for the radius, and r is the distance between the origin and the point. And we can calculate r from the coordinates by the square root of x squared plus y squared. It's derived from the Pythagorean theorem. So it says, complete the following definitions of the trigonometric functions of any angle. So what we're doing then is, again, we're moving away from the triangle and SOHCAHTOA, and now we're going to define all the trig functions on the basis of the point xy and the angle theta. No, not the angle theta, but the distance r. Excuse me, x, y, and r. Okay, so here we are. So the sine of theta is defined as y divided by r. The cosine of theta is x divided by r. And the tangent of theta is y over x. Now, those 3 I've highlighted because those are the ones that I would recommend that you memorize. The other 3 I've got here, cotangent is x over y, secant is r over x, cosecant is r over y. But I don't even memorize those because I just remember the reciprocal functions. And so if I find sine, then I just flip it, and that's going to give me the cosecant, and so on. I just remember which ones are the reciprocal of which. All right, so let me show you how we're going to use this now instead of a triangle. All right, so suppose that we pick a point out here, a point xy at 1, 0. Okay, so then I'm saying that the x value is 1, the y value is 0, and since we're on one of the quadrant axes, to measure r, it's just 1 unit. Okay, you're just counting over 1. So in this example, x is 1, y is 0, and r is 1. All right, any questions so far? So now we can list all of the trigonometric functions for that. So we could say, okay, sine of 0, so this is a 0 degree or 0 radians angle. So the sine of 0 is 0 over 1, y over r, which simplifies to 0. The cosine is x over r, so that's 1 over 1, which is 1. And the tangent of 0 is y over x, so that's 0 over 1, which simplifies to 0. The other three are the reciprocals. So to do the cosecant, if you flip 1 over 0, well, anything over 0 is undefined. The secant, you flip the cosine 1 over 1, and that's still 1. And then the cotangent, again, anything over 0 is going to be undefined. So anytime you get a 0 in the numerator, then it's 0. But if a 0 in a denominator, you'll get undefined. Okay? All right, questions? All right, so let's have you try one. Okay, so it says find the 6 trig functions at theta equals pi halves. So pi halves is what degree in degrees? I mean, what's the angle in degrees? Pi halves.
$180.
180 would be pi. So what would half that be?
90?
90. So 90-degree angle. So right up here, right angle. Okay? So if we pick any point on the positive y-axis, so can anybody name me any point on the positive y-axis going up? So right up here. What's a point?
3.
3.
1.
I need an x value and a y value. So
3.
3, 1 would be off. It's got to be on the y-axis.
3, 0?
So 3, 0 would be on the x-axis.
Okay, so... Okay.
0,
1.
So 0, 3 would be 1. So you can pick any point on that terminal side. Okay? So you could pick 0, 3, or I pick, So I picked 0, 2, but you can pick any one you want. Okay? So just pick a point. 0, 3, 0, 2, 0, 1. Anything on that y-axis that's if the angle is pi halves. All right, now, so you want to write down what x is, what y is, and what r is. Okay, and then plug into those formulas that we started off with and figure out the trig values. So even though we might pick different points, we should all get the same answers for the 6 trig functions. All right, so Leilani, what point did you pick? At the angle of pi halves. So along the positive y-axis. Tell me what point you picked.
6.
Okay, so 0, 6. So then what's x?
Zero.
And what's y?
2.
No. You said you picked the point 0, 6. So if you pick the point 0, 6, the first coordinate is the x coordinate, the second coordinate is the y coordinate. So if you pick 0, 6, then 0 is the x, 6 is the y. And what's r? If you graph that point, how far from the origin is it?
Yeah, this is supposed to be 6, right? Yeah. So just 6, right? No, your y is 6.
So what's the r?
6.
6. Okay? All right. So again, if I pick 0, 2, and so then my x is 0. Let's write that down. So my x is 0, my y is 0, and my r is 2. But 0, 6 is just as good. Okay? You just have to pick some point on that positive y-axis. All right? Any questions so far? Okay. All right, so Billy, what's the sign of pi halves?
Go ahead. 1.
Yeah, so the sign is the y over the r. So that would be 2 over 2. Or if you pick 0, 6, it'd be 6 over 6. Okay? And so no matter what point you pick, the final answer is 1. Okay? Because all of our fractions should simplify to 1. All right? And so, Billy, what would be the cosecant of pi halves?
0. 1. Would it be 0?
It would be 1 because the reciprocal of 1 is 1. So if you have 1 over 1 and you flip it, or 2 over 2 and you flip it, you're still going to end up with 1. So the reciprocal of 1 is just 1. Okay. All right, Ernest, what's the cosine of pi halves?
0.
0. And what's the secant of pi halves?
Undefined.
Undefined. Very good. Okay. Any questions on that? All right, so Leilani, what's the tangent of pi halves?
Would it be 6? 0?
6 over 0. What does that simplify to?
Undefined?
Undefined, because you can't divide by 0. All right? And so the secant of pi halves, or the tangent of pi halves, we said was undefined. So, Leilani, what's the cotangent of pi halves?
Would it be 0?
It would be 0. So you just flip the fraction. So 0 divided by 2 is 0. Okay? All right, good job. Any questions on that? Okay. Whoops. All right, so sine and cosine are defined for all values, all real numbers. So one way to write that is if you use like a bold R, then that stands for all real numbers. So you could just write that, or just all values. Okay? So what does that mean? That means that we can calculate trig values like sine and cosine even for negative angles. And see, we never could do that in geometry because all the angles were from triangles and you don't have negative angles inside a triangle. Okay? So, all right, so let's say that we had, well, this isn't a negative angle, but, excuse me, but this is an angle that's in the second quadrant, 120 degrees. So let's say I wanted to find the trig values for that. Well, let me explain this mess right here, what I'm doing. Okay, so 120 degrees, if I go 120 degrees, that means it's 30 degrees past 90. So that means this is 60 degrees, and so I can form a 30, 60, 90 triangle. Okay, now my expectation is that you know the 30, 60, 90 triangle and the 45, 45, 90 triangle. If you don't, you need to study that, okay? You need to put that in front of you and practice, because I expect you to know those two. So if this is 30, 60, 90, okay, so now so this distance, if I go, remember on a 30, 60, 90 triangle, the shortest side is 1. Now, I've marked it, though, -1 because I'm going to the left of the origin. So the x value would go over to -1. So this is what we call a directed distance. So -1, so -1, 2, and radical 3. Those are the sides of the 30, 60, 90 triangle. All right, so now what we do is, so that means that the x value, this distance over, is -1, and the y value, this distance up, is radical 3. So that means for this problem, the x is -1, the y is radical 3, and the r is 2. Okay, that the hypotenuse here is the distance. Okay, so once I have those, then I can label all my trig functions. So I can say then that the sine is y over r, so radical 3 over 2. The cosecant, I just flip it. Flip the sign, 2 over radical 3. The cosine is x over r, so that would be -1 over 2. The secant, you just flip the fraction, so -2 over 1 is -2. Finally, the tangent is y over x, so that's radical 3 over -1, or negative radical 3. The cotangent, you just flip that and make it -1 over radical 3. All right? Any questions on that? Okay, so what I would like you to do actually is I'm gonna change this practice problem up. So I'm gonna change the angle to -30 degrees. So I want you to find all 6 trig functions for -30 degrees. So you're going to need to draw that triangle again. All right, so this is the triangle. If you're stuck drawing the triangle, figured I'd get you that. So so going down 30 degrees. So here's my 30, 60, 90 triangle. And so 1, 2, radical 3. And this time it's the y value that's going down, so that one's going to be negative. So what's the coordinates of that point?
Square root of 3 and negative 1.
Good. So square root of 3, negative 1. So from that, then, we get, so x equals radical 3, y equals negative 1, and r equals the hypotenuse 2. All right, so Jara, what's the sign of negative 30 degrees?
-2.
So it's y over r. So y would be negative 1, and then the 2 is 2. So it's negative 1/2. So what's the cosecant then, Jara?
Two over -1.
Right. And so then that would simplify to negative 2. Okay. All right. So Billy, what's the cosine of negative 30 degrees?
Square root of 3 over 2.
Wait, you wrote the 2 as negative?
That's right. So x over r. So that's square root of 3 over 2. Good. And so then, Billy, what's the secant of negative 30 degrees?
Are you ready?
2 over square root of 3.
So 2 over the square root of 3. All right. And then finally, the tangent. Caitlin.
-1 over the square root of 3.
Okay. So the tangent is the y over the r. So negative 1 over radical 3. And so then the cotangent of negative 30 would be what?
Negative radical 3.
Right. So you flip the fraction, and then when you simplify, just write the negative in front. All right. Great job. Any questions on any of that? Okay. All right. So next, we want to talk about reference angles. Okay. So evaluating reference angles, the values of the trig functions of non-acute angles can be determined from their values at corresponding acute angles called reference angles. Now, typically when we work it, we kind of hope that the reference angles end up being one of these angles that we know from our special triangles, okay? Now, the way that we denote a reference angle is you put a little tick mark after the variable. So if theta is your angle, then theta prime is your reference angle. Okay, now let me just kind of cut to the chase. I'm going to show you how to find the reference angle in each quadrant. But really what we're doing is we're measuring from the x-axis. Okay? Now, in the first quadrant, you don't need reference angles because they're already acute. So a 30-degree angle is its own reference angle, okay? So you don't have to worry about quadrant 1. But when the angles are not acute, when they're bigger than 90, then you have to find a reference angle. Okay, so this is kind of how you do it. If the angle is in quadrant 2, then again, you're measuring from the x-axis. So that's the straight angle, pi radians or 180 degrees. So if your angle's in quadrant 2, you figure out how far would it take to get to 180. So you subtract from 180 or pi. So like if you have, let's say, 150 degree angle, then the reference angle is you're measuring how far do you have to go to get to 180. So the answer would be 30. So that would be the reference angle. Now, in quadrant 3, you're past 180 or pi, and so you subtract the pi or 180 from the angle. So let's say you're at 190 degrees. Well, you're past 180 by 10 degrees. So that's your reference angle. Okay? And then finally, in quadrant 4, you're measuring up to 360 or 2 pi radians. So like let's say you're at 310 degrees. So that's down here. So then you say, okay, 310, I need another 50 to get up to 360. So 50 degrees would be your reference angle. Okay? So you subtract from 2 pi or 360. So one of the things that we've got to figure out is what quadrant we're in when we're given an angle so that we can figure out the reference angle. Okay, so let's look at this one. So let's say we have 9/8 pi. Well, that's slightly bigger than pi. So pi is the same as 180. That's straight across. It's pi radians. So how much past pi are we? Well, 1/8. 1/8 pi. So that's the reference angle. Okay. All right. So let's say we're at 150 degrees. All right. So 150 degrees is in quadrant 2. So then you say, well, how much farther do I need to go? I need to go 30 degrees. So the reference angle is 30 degrees. Okay. All right. Well, let's work through these reference angles. So we'll start with So practice 2A. We're going to find theta prime or the reference angle. All right, so Andy, when you've got it. So, Andy, 210 degrees is in what quadrant?
Quadrant 3.
Quadrant 3.
Otherwise, it would be
So
100.
when you're in quadrant 3, then you're past 180. So how much past are you?
Yeah. Makes sense.
30 degrees.
30 degrees. So that's the answer.
Okay.
So the reference angle is 30 degrees, and so you would so you could say 210 minus 180 is 30 degrees. So that's your theta prime, and you're in quadrant 3. Okay. Any questions on that? All right. So now try B. B is probably the trickiest one of all of them. So I'll let you think about it for a minute. All right. Can anybody, I'll just let anybody that thinks they want to take a stab at this answer. Because this is the trickiest one here. Okay, so is 4.1, is that degrees or radians?
Is it radians?
It's radians. Because if there's no degree symbol, you have to assume it's radians. Okay? So what quadrant is 4.1 radians?
3 or the third.
Excellent. That's in quadrant 3. Because 4.1 is bigger than what's 180 degrees in radians?
Pi.
Pi. So 4.1 is bigger than pi. How much bigger?
Almost one
So how
bigger.
did we get the exact value?
Could you reverse it into degrees and then do it?
It's too hard. There's a much easier way. So I want to know how much farther is 4.1 than pi.
Do you subtract 4.1 by pi?
And so what do you get?
0.9584.
And so that's your answer. That's your answer in radians. Okay? So you're in quadrant 3. So you're going to subtract pi from 4.1. So your reference angle is 0.958 radians. Because you're past pi. And so to figure out how much past, you just subtract. Okay? All right? Questions on that? All right, well, let's try the next one. All right, Tangio, when you've got it.
Is it 80?
Is it 80 degrees? It is 80 degrees. Good job. Any questions on that? Okay. All right, let's try the next one. All right, Porter, when you've got it.
Is it in quadrant 4?
Yes?
And it's 60 degrees?
It sure is. Okay, good job. All right, now the last one. All right, Akima.
Is it 30 degrees?
Yeah, it's 30 degrees or pi 6. See, this one's almost so easy, it's tricky. Because, see, if you're going down pi 6 radians, then from the x-axis, then the angle to get you back up is going to be pi 6. Or let's say you went down 20 degrees, then the reference angle would be positive 20 degrees. Or if you went down 30 degrees, the reference angle would be 30 degrees. So the reference angle is always going to be positive. Okay? So for this one, you would say the answer is either pi 6 or 30 degrees. Okay? All right. So any questions on any of those? All right. Next, we want to talk about the signs of the signs. Well, the signs of all the trig functions. Okay. Now, the way to remember the signs is of the trig functions is to remember this acronym ASTC, and I'll explain what that means. So ASTC. So what we're looking at here are in the 4 quadrants is we're looking at sine, cosine, and tangent because their reciprocals would have the same sign, positive or negative. So what we're going to do is if we look at in quadrant 1, the sine, cosine, and the tangent are all positive. So this is telling us where they're positive. So all, and so we put an A there. They're all positive. In quadrant 2, the sine is positive, but the cosine and tangent are negative. So we just put an S for sine, because it's the positive one. In quadrant 3, the sine and cosine are negative, but the tangent is positive, because it's negative divided by negative. So we put a T there. And then in quadrant 4, it's just the cosine that's positive. So we put a C there. So A, S, T, C. So the way that I remember that is, let's see, did I put on here? So the way I remember that is, well, I guess I didn't put it here. Okay, here, I'll just write it here. It's awesome students take calculus. Okay, here, I'll type that up there. So awesome students take calculus. Now, somebody told me Mr. Fritz uses all students take calculus, but that's not quite true. Okay? That one just put it right there. Okay, so on the back of your sheet, go ahead and circle where the functions are positive and negative, or where they're positive. Okay, so just go ahead and do that. Okay, so go ahead and check your work. All right, does anyone have any questions on any of those? Okay. All right. So the next screen says to find the value of any trigonometric function at any angle. There's 3 steps. Okay, so number 1, we're going to find the reference angle. Number 2, we use that awesome students take calculus to figure out if the sign is positive or negative. And then number 3, we find the trig value at the reference angle. So when it says find the exact value, that is kind of my way of telling you we're not using the calculator for this. We're using our reference angles and we're using the triangles that we know. Okay? So let's say I wanted the cosine of 7 pi 6. So step 1, you find the reference angle. Well, 7 pi 6 is slightly bigger than 1 pi. How much bigger? Seven
1/6
six
pi?
What?
1/6 pi.
Yeah, 1/6 pi or pi 6. So that's the reference angle. Okay? So step 1, the reference angle is pi 6. Now, if you would prefer to convert these to degrees and do them in degrees, you're welcome to do that. All right, next. Okay, we're in quadrant 3. Is the cosine positive or negative in quadrant 3? Anybody? Just tell me. Quadrant 3.
It's negative.
It's negative. So then you put a negative. All right, now the trig value. So we need to find the cosine of pi 6 or 30 degrees. So my expectation is that you know the special triangles or that you can quickly get it. Okay? So if you don't know them, you need to be practicing that so that you don't have to hunt it up every time. Does anyone know what's the cosine of pi 6 or 30 degrees? Okay, it's radical 3 over 2. And so then the final answer, you put the negative with it, so it's negative radical 3 over 2. Okay? All right, so what I would like you to do for before class on Tuesday is I want you to do practice 2, both problems, 1 and 2. So evaluate those 2 using reference angles. Okay? And then we'll pick it up from there. So no broadcast Monday. You're going to do the Moodle quiz on 6-2. Okay? Good luck. Have a great weekend. Be safe. And I'll see you on Tuesday.